Good afternoon, everyone. Can you hear me well? Hello, can you hear me?
Yes, doctor, good evening.
Oh, good.
Yes,
Good,
doctor.
okay. Yeah, so let me share my screen. Okay, we need to open the document, the book, textbook. Okay, so this should be somewhere here. Okay, so we've got a little homework for today. I just want to do the homework and discuss the case of three equations and three unknowns very quickly before we move on to the algebra of equations. Okay? So I guess we had this one 1.1.1 and 1.1.2, right? These two exercises. So I will do them very quickly in Geogebra. In fact, many of you sent me their solutions. And it seems, you see, there's a problem to how to send the solutions, which I don't know the solution to. What I'm going to do next time is to create an assignment. I should have created an assignment, so there is here assignment here, so I can create an assignment in the current channel here, let's say, and then you can, I hope you will be able to upload your solutions to the assignment. Okay? I've never done it before. But I'm going to try it next time. So not this time, the time after, maybe on Thursday, I will assign homework over the weekend. If you solve it, you can send the solutions, or you can upload the solutions to the assignment, I think. Have you ever tried to use assignments before?
Yes. Yes.
Okay, so you can upload your solutions, right?
Yes, doctor.
Yes, doctor.
Good, okay. Okay, so the first question, let me run GeoGebra. So it's to graph these two equations, right? And see whether there is an intersection. And of course, as we remember, the intersection, if it's existent, then it's the solution of these two equations, right? So let's go here, run GeoGebra. Where is GeoGebra? Just a minute. GeoGebra is somewhere here. Okay, so the first equation is x plus 3y equals 1. Let's plug it in GeoGebra in here. Okay. Just plug it, and this is a straight line, right? The second one is this equation, 4x minus, oops, what happened? Okay, the lights went out here, so I need to wait until they come on again, okay? Just wait for me, please. Okay, so my screen is off now, I see nothing. Okay, the screen is on. Can you hear me?
Yes, doctor.
Yes,
Yes,
doctor.
Good. Okay, so here's the second equation, and here are the two lines, right? And you see that they do intersect, right? And this point of intersection, which we can easily find in GeoGebra. So there is here, where is it? It's here, yeah, intersection. So we can even find the coordinates of this point. So this is it, it's A, right? And the coordinates are 0.77 and 0.077. Okay, this is the point A. So this system, as we remember, this system is said to be consistent, right? Because it admits a solution. Of course, there could be many solutions, not necessarily one, right? For the system to be consistent. But if there is no solution, then we say that the system is inconsistent, right? It doesn't admit a solution. Okay, the second one is also very similar. Okay, so this is 3x plus y equal 3. So I'm going to copy the equations again into GeoGebra. Let me replace here this one. Let's say this one. So this is the line. Okay, and the other one is this, which of course is another line, right? So we can plug it in here instead of this one here. And this is what we get. And you can see that again, that the two lines intersect. And in this case here, the point of intersection is at 1, 0. The abscissa is 1 and the ordinate is 0, right? The y coordinate is 0. That's it. A fairly simple, a fairly simple homework, right? Yeah, of course, because we are just starting. Of course, it's going to be simple, but not as simple as this one. This is very simple, and of course, it's very familiar to you. Do you have any questions about the homework? Let me switch to here. Do you have any questions about the homework?
No, doctor.
Okay. Then let me tell you about now a system of 3 equations in 3 unknowns. So how can you graphically interpret such a system? So remember, when we have 2 equations into unknowns, or maybe more than 2 equations, let's say 3 equations into unknowns, of course, if they are linear, remember, then the interpretation is fairly simple. Each equation is represented by a straight line, and the intersection point of all these lines, if it exists, is going to be the solution of the system. So for example, here, just to remind you, in the left-hand side picture here, there is no solution. You have now here 3 equations. The red equation, which is the red line, of course, the blue one and the green one. And you see that they don't have a point in common, right? There is no point in common for the 3 lines, so there is no solution here. And here, in this case, all the lines intersect at a single point, which is the common solution to the system of 3 equations into unknowns. Okay, but now what about having more unknowns? Let's say 3 unknowns. Can you also give a geometric interpretation to the system and to its solution? It turns out, yes, of course, you can do it in 3 dimensions, or in the case of 3 unknowns. But unfortunately, you can't do it for higher dimensions or more unknowns. Let's say 4 unknowns or 5 unknowns. Simply because the geometry that we live in is 3-dimensional, right? We have only 3 dimensions, so we can manipulate only 3 unknowns, but there is no way we can see what's going on with 4 unknowns or 5 unknowns, because each unknown will be represented by an axis. Let's say the x-axis, the y-axis, and the z-axis, and that's it, right? We have exhausted all the dimensions of 3 space, and you can draw a 4th dimension or a 5th dimension, right? That's it. But in 3D, it still works. We can do it. Okay, and let me show you now. So let's take let's say this equation. Okay, suppose I take this equation. This is now, you see, three unknowns, right? X, Y, and Z. Okay, and I'm going to plot it in GeoGebra. So let me erase all these since we won't need them. And I will show you now the 3D graphics. So you may be familiar with this. In GeoGebra, there is 2D and 3D. Let me close the 2D. We'll keep now the 3D. Let me erase this plane. Okay, and now every equation I plot, it's going to be not a straight line now, it's going to be a plane, right? So for example, this equation now, you see, is a plane, and let me now rotate it so you can see what's going on. You see, this is the plane. Now maybe I'm doing it a little bit too fast. Okay? But essentially, you see, I have this blue plane, and in this case, I think that the x-axis is the green one. The green line is the x-axis. The red axis is the y-axis is the red one, and the z-axis is the blue one. Okay, and you see that my equation, this one, is represented by a plane. So what does this mean? This means that any point on this plane will have x, y, and z coordinates which satisfy this equation. Okay, so for example, let's see, if I take x to be 1, let's say, okay, and y to be 1, maybe I shouldn't take 1. Let me take y to be 0. No, I will take z to be 0. Okay, and what do you think y should be now to make it true? Or let me take x to be 0 also, just to make it easy for you. So what coordinate, what y coordinate would make this equation true? What do you think? Hello? Are you here?
Equation, doctor.
Can you see the equation in Geogebra? Let me wait a bit. Let me switch to Geogebra and make it a little bit larger. I will increase the font. Let me remember, how can I do this? Settings, just a minute. Increase the font so you can see it better. Okay, so this is the equation. You see it? Here's the equation. Let me make it slightly larger. This is the equation. You see? Here it is. Okay, what is this A here? I don't need this A. Okay, and I'm asking now for a point, right? I want the x coordinate to be 0, the y coordinate I'm not going to tell you, and the z coordinate is 0. What y coordinate now will make this point here? Let's call it a name. Let's call the point A, for example, right? So which y coordinate will make the point lie on the plane? What do you think?
2.
2.
Of course, 2. Yeah, absolutely right. Yeah, 2, of course. And now I will try to show you this point A. You can see it. It is here. Let me. Okay, now it's not very visible, so I'm going to do something about this axis because the axis here is creating a mess. So let me try to maybe remove the numbers here. Let me not show the axes. Okay, so I removed the axes. You see this point here? It's smack on the plane. Do you see it? It's on the plane, right? So this is one point, right, which is on the plane. Of course, I can produce another point. You see, I'm moving it now. Maybe I moved it off plane. No, it's still on the plane. You see, and now all these points here. You see, all these points. I can move them around. They are all on the plane. So this means that this plane, right, is giving me all the points whose coordinates x, y, and z, okay, satisfy this equation. 2x plus 4y minus 5z equals to 8, right? So you see now that our equation now is a plane. It's not a straight line in the plane. It's now a plane in space, right? It's a plane in space. And of course, you may have more than one equation. Of course, now solving a single equation like this is fairly simple, right? But usually you don't have a single equation, you have many equations. So let me now go to the book and copy maybe the next equation if there is one. No, there isn't. Well, let's just try to write our equation. So let's write another equation here, okay? For example, x plus y, let's say, minus z, right, equals 0, okay? And I will change now the color. Okay, let me change the color of this so you can see it better. Let me make it maybe pink. Okay, so now I have two planes. You see, the blue plane, which is given by this equation, and I have the pink plane, which is given by this equation, right? And you see that these two planes intersect in a straight line. Do you see it? It's this line here, right? This line here, and these are the points which are common to the pink plane and to the blue plane, right? And these points have x, y, and z, right, which satisfy the first equation as well as the second equation, right? So these x, y, and z are solutions to this pair of equations, right? So the solution now in this case, you see, is just a straight line. Yeah? So remember, in the case of two unknowns, two equations had one solution. or an infinite number of solutions if the two lines were coincident or confounded, and no solution if it is parallel. In this case here, two planes in general would have a line of intersection, right? A whole line of intersection, and all these points on the intersection, their coordinates are going to be the solutions to this system, right? But of course, in some cases, you may have equations which do not admit solutions. So now, before I proceed, do you have any questions?
Doctor, I have a question.
Yes.
When we were working on 2 dimensions, we were using in a system 2 equations. But I guess when we are working in 3 dimensions, can we still work on only 2 equations? Don't we need 3 equations?
No, it's not about needing. I mean, it depends on what you are solving. If you are solving a problem, the problem will tell you how many equations there are. And usually you may have any number of equations. So there is no relation between the number of unknowns and the number of equations. You may have one equation, you have 2 equations, you may have 3 equations, or you may even have more equations than unknowns, right? Like, for example, the case that we considered earlier. Remember this case here where you had the lines here? Here we had 2 unknowns, right? But 3 equations. So there is no direct relation between the number of equations and the number of unknowns. But if you are hoping to find a single solution, right? If you want to find a unique solution, then this is usually the case when you have an equal number of equations if you are hoping for a single solution, a unique solution. But in general, as I said, there is no direct relation between the number of solutions and of unknowns and equations. Okay, but of course I can of course take here another plane, a third plane, right? So let's do it. Maybe I'll keep it easy. Let's say x minus y just equals 0. Okay, and let me now change its color also so you can see it better. Maybe I'll make it now what brown, let's say. Okay, so now let me hide it so you can see. So remember, these 2 planes intersected each other in this line. Let me also show you this line, because here there is an option. I can show you this line. So this plane and this plane, you see they intersected each other in this line. And now when I add my new equation, you see, now this new equation is going to intersect now the line. What happened? Why? You see, it's going to intersect the line at a certain point. You see it? I'm going to change the perspective so you can see better. This is the point of intersection here. You see it? This one here. Okay, and this is the solution of the 3 equations. Okay, so 2 equations intersect, or 2 equations, if you like, they represent 2 planes intersecting in a straight line. And now when you add a third equation, you are adding a third plane, which in general is going to intersect your line in a point. Okay, but of course it may be different sometimes. It may not intersect it at all. Like there's an example in the book here. So here are the 2 planes which intersect in this line, you see. But if you add now a new plane, like this one here, you see, here, this new plane, it happens so that it's parallel to the second plane, or the first plane, if you want, right? And in that case, there would be no intersection between this plane and the line of intersection, right? And in this case, there would be no solution. This is similar to this case, right? Where you had 2 lines already intersecting and you added a third one, which does not go through the point of intersection. It goes the side, to the left or to the right, right? And here too, we had 2 planes which intersected in a straight line, right? And we added now a new plane which misses the line completely. It doesn't cut the line, right? And then there will be no solution in this case. So if you have a system of such equations, right, there will be no solution. I can show you an example in Geogebra, and to keep it simple, look what I'm going to do. I'm going to cheat a little bit, but I'm not going to tell you how I'm cheating. Okay, but I will cheat. 2.5, let's say, plus, I don't know, maybe plus 2. Okay. And now let me see, did I do it correctly? Let me check. I think yes. minus 2.5 z. Oh, okay, I missed the z here. That's why I got something wrong here. Z. Okay, now I think I have it. Okay, so now let me hide the third plane. Okay, so look at the first two planes. Here they are. They are still intersecting in this line. You see the blue line, or yeah, the dark blue line, right? And now if I add now the third plane, if you look carefully at it, let me show it now. You see it misses a line. Do you see? There is no intersection between the plane and the line. You see it now? You see it better, perhaps. Let me make it larger. Okay, so you can see. Oops, this is too much. This is it. You see, this new plane does not intersect the line. You see, and this means that our system, these three equations, right, do not have a solution, because the first two planes intersect in a line. The third plane doesn't have anything in common with that line, so there will be no point which satisfies the three equations. Right? Do you have a question about this? Let me switch to here.
دكتور يعني بدي أسأل شغلة هلا
Yeah. Yes, Sarah.
اوكي هلا يعني الفرق بينه وبين لما يكون عندي equation of a line هي انه الانترسكشن بالبلينز بتصير هي عبارة عن line هو الانترسكشن مش point وحدة.
Right.
وبصيروا
Absolutely
كل
right.
النقط اللي على هيدا اللاين الانترسكشن هو هن solution لهدوليك equations.
Right. Absolutely right. Yeah. Absolutely right. Yes. Yeah. Right. Right. And now, if you add now a third equation, you want to find now the solution is going to be now a point which is common to the three planes. So the point should be on the three planes at the same time, which means it should already be on the straight line of the two planes where they intersected, and it should be on the new plane, right? So this means that the new plane has to intersect the line, which it doesn't in this case. You see, this is the line. In my case here, this is a blue line, the intersection of the two planes, you see? And this blue line does not intersect the brown plane, the new one, this one, the new equation. So this means that there is no solution that satisfies the two equations and at the same time the third equation. There is no such solution. Okay, but now if I change this a little bit, let's say I make it here perhaps maybe 1, okay, instead make it 1 here instead. Okay, now you see that there is now a solution. You see now the brown plane is cutting the blue line. Do you see there is an intersection now between the brown plane and the blue line? It's here, this point. Do we all see it?
Yes.
Okay, and this is the solution. At this point, the coordinate of this point, x, y, z coordinates, are the solutions to the three equations. Okay, so you see that even in the case of three unknowns, we also have a nice geometric interpretation of the system and its solutions, right? So the system is going to be a system of planes, and the planes can either intersect at a single point or not intersect at a single point, as the case I showed you earlier, okay? So this is what I want you to know as far as the geometric interpretation of three unknowns goes, okay? So I want you to know only this and no more than that, because I know that many of you are coming from the sociology and the economics background and have not seen plane previously, so I'm not going to teach you this now to use it, right? So that's what I want you to know about the interpretation, geometric interpretation of three unknowns. Okay. Do you have any questions? Okay. And then now we start now the algebra. Okay, so now the introduction is over. That's it. So this was an introduction, just to remind you what linear equations are, how to give them an interpretation, a geometric interpretation. And now we'll start now something which at the beginning will look familiar, which is good because you will be able to find your way. But later it will be completely new. Okay, so let me start. I'm using a book. You can follow if you like, I don't know, on your device, or you can follow on the screen here, right? So now we start the algebra of the equations, okay? So if I give you an equation, the question is, what are you going to do to solve it? This is a question. And not only this, how can you tell whether the equation admits a solution in the first place before you begin even solving it, right? Whether it admits a solution, and if it admits a unique solution or maybe infinitely many solutions, right? So we will learn all this stuff in not only in this chapter, in the course, okay? But now in this section, I will just remind you of the basics of solving equations. So what do you do to solve the equations, okay? Okay, so now we'll have a lot of terms which you need to learn, okay? So a system of linear equations looks like this, okay? So what is this? This is the first equation in the system, right? This is the second equation in the system, the next one here, and so on. And there are, look how many equations, there are m equations, okay? What is this number m? It can be any. It can be 2 equations, it can be 3 equations, it can be even 4 equations, 5, whatever, okay? So m is the number of equations. So you see this little m here is the number of equations. So this is the first equation, okay? B1, the second equation where you have B2 in the right-hand side, and then we have the equation number m, right? On the other hand, how many unknowns are there? There are n unknowns, right? And now, instead of calling them x, y, and z, right, we're going to call them x1, x2, x3, x4, and so on up to xn, because, I mean, if you are going to call them x, y, and z, the alphabet will not be enough, right, to label them. So instead of using the alphabet, we're going to use a single symbol, x, right, and now use a subscript, which is this index underneath of the symbol x, x1, x2, x3, to label the unknowns, okay? So x1 is just our x, our old x, x2 is our old y, x3 is z, and x4 is something else, and x5 is yet another unknown, and so on, okay? So now the unknowns are labeled x1, x2, up to xn, and the equations are labeled 1, 2 to m, okay? So there are m equations, and there are n unknowns, okay? Now, these numbers, which are, you see, the coefficients of the unknowns in each equation, okay? These are called the coefficients of the equations. So the first equation has coefficient a11 x1. Okay, this is the coefficient a11. This is the coefficient of x1. Right? A12 is a coefficient of x2, and a1n is a coefficient of xn. So notice that all these a's here, you see, they have the first subscript 1, here 1, and here 1. You see why? Because this is the first equation. Okay, so we label all the coefficients, okay, with the first index or the first subscript 1, just to indicate that it is the first equation. Okay, now the second subscript, okay, is just the same as for the unknown. So this is a11 x1. You see, this one is the same as this one, and then this 2 is the same as this 2 here. See, and then this n is the same as this n. So in other words, every a, let me just pick my annotation tool so I can write. Do you have any question in the meantime? Do you have any questions? No questions? Okay. So this a ij, okay. So ij, where I is the number of the equation. You see this, it's called the subscript, okay? This subscript is the number of equation. So here we have equation number 1, and then equation number 2, and then equation number m, right? And this is the number of the unknown, okay? So it tells you what unknown it is multiplying. It's multiplying the first unknown, the second unknown, the nth unknown, whatever it is, okay? And the collection of these numbers, okay, is called the coefficients of the equation, the coefficients, okay? Can somebody figure out how many there are? If we have m equations, okay, and we have n unknowns, okay, how many of these will there be? How many coefficients will there be?
N.
I can't hear you.
N.
Repeat, doctor.
Yeah, I can't hear very well what you are saying. Somebody said something.
And unknowns.
Why? No, I'm not asking about the unknowns. Wait a bit. Let me get my question clear. I'm not asking you about the unknowns. I'm asking you about the coefficients. Okay, it's all erased now. So yeah, this is a problem with the annotation tool. So let me, instead of using the annotation tool, let me use my Jamboard. Just a minute, please. Okay, so what I'm asking you is this, right? So let me, do you know what? Let me try to copy if possible. I'm not sure that I can copy. Where is the book? Okay, the book is here, right? I'm not sure that I can copy. What?
M times n.
M times n, yeah. Okay, why? Yeah, why? Let me see, can I copy this? Copy, no copy. No copy. I can't copy it. So I'm going to rewrite it. Okay, just a minute. Going to rewrite it, and it's here. Okay, so here how it looks. It looks like this. So we have a11 x1, okay, plus a12 x2, okay, plus, and here we have a1n xn, okay. And this is equal to B1. You remember, this is the first equation. And then we write the second equation, which has now A21x1. You see now, the first subscript, this one here, is the number of the equation. It's the second equation now. Okay, so this is x2, sorry, x1, not x2, x1, plus A22, right, x2, plus, and then we go all the way to a to n, right? Again, it's 2 because it's second equation. Now the nth unknown, whatever the n is, equal to b2 now, the second equation, okay? And then we continue in this fashion until we get to the very last equation, which I will call now m, number m, some m. M can be any number, okay? Still am1 x1 plus am2 x2, right? And so on to the very last term in the very last equation, which is amn xn, all right? Equal to bm. Okay, and now my question was, okay, how many equations are there? Of course, there are m equations, right? There are m equations. And how many unknowns are there? Okay, there are n unknowns, right? There are n unknowns. Then these coefficients, let me circle them in red. These coefficients, how many are there? Oops, how many are there of these? These coefficients, how many? Okay, so in the first equation, there are how many in the first equation? There are n, right? In the first equation, there are n, right? Okay, in the second equation, how many are there?
Also n.
Also n, right? And in the third equation, there will also be n, okay? So how many n's will there be? There will be m of them, right? M n's, right? So in total, the coefficients a, I, j, right? The number of these is, somebody said, right? Just m times n. Now, for example, if I take 3 equations, let's say, so m is 3, okay, and I take 2 unknowns. This is the equation that we saw previously. Remember last time, 3 straight lines in the plane. Okay. Then how many coefficients will there be? These aij's. There will be 6 of them, right? There will be 6 of them, and we know this because let me just take you to the book and try to count them. Okay, just to make sure that we understand. Everyone understands what we are talking about. Okay. So let's take an example where we have 3 equations. I think we had one. Okay, no, not here. Maybe I gave you one in my previous Jamboard, right? Didn't I? I think I did. So what I'm going to do now is go to Jamboard and show you our previous jam, which I can see here somewhere. Just a minute. Here I think I had, or maybe we didn't, I'm not sure. Did we? No, we didn't. Yeah, we didn't. Okay, so let me go back to. Okay, I'll give you another one now. So it's so easy, but it's going to take some time. So let's take an example of this. So 3 equations, 2 unknowns. For example, let's say x minus y, right, equals 5, suppose, okay? Then suppose 2x plus y equals, I don't know, minus 2, okay? And then we'll have, let's say, y equals, a very simple one, y is equal to 7, let's say. Okay, now, so this is a system of 3 equations, right, in 2 unknowns, right? So this is the case, m equal 3 equations. Equation number 1, right? Equation number 2, okay? And equation number 3. Okay. Now, can somebody tell me what is the coefficient A11? A11, you see? What is the coefficient A11? 1. Yeah, absolutely right. Because this is the coefficient which is here. Let me label it in red so you can see. It's the coefficient which is multiplying the x, right? This one here, the one that stands here. And of course, here we have a 1, right? We have a 1 here. So this coefficient A11, in this case, A11 is just 1. Okay. What about A21?
2.
Yeah, A21 is 2. Yeah, because this is the coefficient of x in the second equation. You see, this label here is asking you for the second equation, A21. So it's telling you the coefficient of the first unknown in the second equation. See, or if you like, the coefficient in the second equation of the first unknown. Okay, and finally, let's say A31. What do you think it is?
0.
Yeah, there is no x. You see, yeah, there is no x. Absolutely right. It's 0. Right. It's 0. Right. Okay. Let's do it now for the y. Okay. So let's say what is A12? A12 in this case?
Minus 1.
Minus 1. Right. Okay. And A22?
1.
Plus
A22 is
1.
Yeah. And finally A32?
Also 1.
A32 is 1. Okay, and now let's finish it. These B's now, the B1, B2, and BM. So what is B1 in this case here?
5.
The right-hand side. You see, the B's are in the right-hand side. Here they are. You see, these are the right-hand side. Okay, this is 5, right? And B2 is minus 2.
Minus 2.
Minus 2. And B3 is just 7, right?
7.
That's it. So this is the meaning of these coefficients, okay? So again, these are called the coefficients. The A's are called the coefficients of the unknowns. And the B's are called the right-hand sides of the equations because they appear in the right-hand side, as you can see. Okay. Now, later we are going to group them into a vector and a matrix, but this will come later, okay? For now, we'll just treat them separately. I mean, and the coefficients and B's. Do you have any questions about this?
No, doctor.
Let's continue then. Let me move back to the book. Let me go back to the book then. Okay, the book is here. Okay, now I hope you are familiar with this notation, the sigma, right? So the sigma, it tells you just the sum, right? So you just add. And what are we adding? We are adding the products of the A's by the X over the J, right? So the sum here is not over the I is not changing, the I is fixed, right? And the J is changing. So the J, it's changing from 1 to n. These are the unknowns, see? So we are adding, so this term here, plus this term here, plus this term here. We can write all the left-hand side using what is called usually the sigma notation, okay? Now, I'm not going to use the sigma notation, so you may not worry about the sigma notation if you are not familiar with it, but I assume that you have seen it in school. If you haven't, okay, forget about the sigma notation, okay? Good. Now, in case when the right-hand side is 0, all of them are 0, okay? B1, B2, B3, and all the way down to the very last one. In case when all of them are 0, the system of linear equations, okay, is said to be homogeneous, okay? So remember this term, homogeneous, okay? This means simply that the right-hand side, all of them are zeros, okay? Not only a few of them, okay? All of them must be 0. All of them must be 0. If they are zeros, then we say that the system is homogeneous. Okay. Now, notice also that, for example, in my example here, I could write the 5 here to the left, right? And then I would get a 0, but the equation would not be homogeneous. For example, this equation, I could rewrite it this way. I could write it as x minus y minus 5 equals 0, right? But this is not a homogeneous equation, despite the fact that you have a 0 in the right-hand side, because here you have the two unknowns, x and y, and you have something which is not a coefficient of an unknown, you see? This is just a number. So it shouldn't be this way. This is not homogeneous, right? This equation is not homogeneous, okay? To be homogeneous, the left-hand side should all contain the unknowns, x1, x2, x3, and so on, okay? And the right-hand side must be 0. Okay, keep this in mind, please. Any questions? Okay, then let's go back to the book and see what's coming next. Okay. So this definition we already gave, but it's good to remember. Okay, so a system of linear equations is, remember, if there exists at least one solution. Okay, otherwise it's called inconsistent. If there is no solution, then the system is said to be an inconsistent system. Of course, the x1, x2, xn, which satisfy the system, which make it true, right, is called the solution set. Okay, so when we are finding the values of x1, x2, and xn, right, which will make this system true, then we say that we are finding the solution set of the equation. Okay, and why set? Because in general you may have more than one solution, not necessarily a single solution. You may have infinitely many solutions, as we have seen in the case of two unknowns, right? So any solution x1, x2, and xn, right, is an element of the solution set. Okay, so any set of numbers which make this system true is said to be a solution, and it belongs to the solution set of the system. Okay, so in general we speak of the solution set, right? And this set could be empty in case when there is no solution, the system is inconsistent, right? It could contain only one element if the solution is unique, and it could be infinite if there are infinitely many solutions. Okay, so these are the expected, if you like, results when you are solving a system of equations, linear equations. You can get either an empty set of solutions, meaning that the system is inconsistent, or you can get a unique solution, okay? Or you can get infinitely many solutions. So this means that the set has infinitely many elements in it. Okay. Any questions? So this is all this is about the terminology yet. So we haven't started yet now the solution, how to solve it. I'm just introducing a little bit of terms that we are going to use all the time. Okay, do you have any questions?
No, doctor.
Okay, good. And now let me see what's the time. Okay, we still have 5 minutes. I think we can do something in 5 minutes. Okay, so now we come to the solution. So how do we solve a system of equations, right? So if I give you, let's say, such a system of two equations and two unknowns, right? Now, forget about the graphical interpretation, the intersection of two lines. This is not going to help you a lot when it comes to finding a solution, right? But now, how can you solve it? How can you solve the system? Now, of course, one way is to try, right? try points, but this is of course pointless. I mean, if you are going to try points, you may try infinitely many points and none of them would work, right? So you will waste all your time just trying points. Nobody does it this way, right? So what we do is we perform some operations on the system, right? We change the system slightly so we can see better what the system is telling us, right? In this particular case, as you may remember, what you do is you simply add the equations, right? If you just add the equations, okay, so I will write here, add the equations. What do we get then in this case? If I add the equations, okay? If I add the equations, you see what happens. The left-hand side, this x and this x, right, will get cancelled because one is positive x, the other one is negative x, so they cancel, and you will get 2y, right, equals 8. Right? Now, you see, this equation is, it's nothing new. We got it from here, right? This is not a new equation. This is a consequence of these two, okay? But this equation is very simple because I know how to solve it. There's only one unknown in it. There's only one unknown, y, and I know that in this case, the value is going to be 4, right? And now, once I have found this value of y, I can go back to one of these equations, right, and find the value of x. For example, I can use the first equation, right? From the first equation, I would get x plus 4 equals 3, right? And from here, it follows that the x is equal to -1. Oops, I can't erase it, sorry, so let me just strike it. And this x is equal to -1, okay? So what have we done? The things that we have done are called elementary operations. So what are these operations? In this case, we simply added the two equations, right? We just added the two equations. And it turned out that the resulting equation is very simple. We could simply solve it, right? And once we have found the solution, we substituted it back, right? And this is called back substitution in the system to find the other unknown, right? which was x here in this case. Okay, so the elementary operations are many, not only this one, not only addition. So what are the elementary operations? There are 3 elementary operations which you can do on a system of equations. The first one is to switch the order. So make the first equation, let's say the second, or make it the third, and take the third, make it the first, right? So you can simply change their order of the equations. This is one. The second thing is you can multiply the equation by a number. For example, this equation, you can multiply it, let's say, by 2, this equation here, and it would read then 2x plus 2y is equal to 6, right? This equation is exactly the same as this one. There's nothing new in it, right? You can get from one to the other by either multiplying by 2 or dividing by 2. And these equations are exactly the same. So one thing is to switch the order. The other operation is to multiply an equation by a number. And the third operation is to add or subtract an equation from another one, or add it to another equation, right? These are the 3 operations. And it turns out that by performing these operations in the right order, you can always solve any system of linear equations. And this is what we're going to show next. Okay, so here are the 3 operations which you need to remember. Okay, first, change the order of the operations, multiply by a number. Of course, it has to be non-zero, right? Because if you multiply by 0, then it will be 0 equals 0. Yeah, of course, you knew this, that 0 is equal to 0 always, right? But it contains nothing new in it. There's no information in it, right? So if I go back to my equation, let's say here, right, and I multiply the left-hand side by 0 and the right-hand side by 0, then it would say 0 equals 0. Yeah, but this is not very helpful. You see, I always knew that 0 is equal to 0. Right? So this is not a nice thing to do. So you should never multiply by 0, because if you do multiply by 0, it will not give you anything new. Okay, so do not multiply. Of course, you shouldn't divide by 0. This is for sure, right? But also not even multiply, because it's not going to add a new equation for you. Okay? And the third operation is to what? Is to replace an equation by the sum, as we did. Remember, we multiplied, we added two equations, right? And we replaced, let's say, the last equation by this result, okay? So here, okay, it's erased already, but when we added two equations, we got 2y equals to 8, right? And then we solved it, and we substituted the answer in equation number 1. So effectively, we have used this equation together with this equation, right? So we have replaced this one, we have replaced it by this one, okay? We have simply, as if we erased this and replaced it by a simpler equation, which is the sum of the two, okay? So these are the operations. And next time, we're going to see how to use operations to solve any system of linear equations. Okay. I'm going to stop here for today. Do you have any questions before we dismiss?
No,
No,
Dr.
doctor,
Yasser.
thank you.
Okay. See you on Thursday then. Bye.